to study in this course. So here mainly it consists of the studying. Already we have come across the basic idea of how the Ohm's law can be applicable and how the Kirchhoff's voltage law, Kirchhoff's current law can be applicable, and the resistance in series parallel. All those things will be having the idea. So based on that one, you're going to see the concepts, fundamental concepts of how to reduce the complex network and how to apply the mesh analysis, node analysis, and till the advanced topics you're going to study in this subject. So first, before starting the actual theory, actual concepts, let us look into some of the course content of the network theory. So with this idea, we can go for the taking the subject and we'll study the concepts in detail. So let us look the overview of the network theory. So usually in this subject, you're going to understand the concepts of the network circuits, and we are going to see how to find the current and voltage in the across any of the circuit elements, such as the resistors, it may be capacitor or it may be the inductor, in presence of the AC and DC sources. Afterwards, you're going to apply the network theorems, and we are going to see how to reduce the complex network or how to find out the current or voltage in the near part of the networks. And we have many theorems are there, almost 6 theorems are there. Afterwards, you are going to see the initial and the final condition, the switching conditions you're going to see in the network, and the resonance concepts, and also the concepts of Laplace transform to solve the complex networks, and many more topics you're going to study in these subjects. The prerequisite for this course will be some of the basic components, like we should know Ohm's law and the concept of how to reduce the complex network, that's resistance in series and resistance in parallel. All those things is required. These are the prerequisite for the network theory. Now let us look into the course content of the network theory. So we'll begin with the module 1. So in the module 1, you're going to see the concepts of the basic concepts you're going to see. The concepts will be something like the practical sources. So there are different types of sources are there. One is called as the dependent sources, other one is called as the independent sources. And the many practical current and the voltage sources are there. We are going to see those practical kind of sources we are going to see. And later we are going to see the concept of the source transformation, because if any network consists of a complex network will be there where the multiple sources are there, like the current and the voltage sources. So these sources has to be converted into the simplest form, and we need to find out the current or voltage across any part of the network. So by applying the concept of the source transformation and the concept of the V shift is nothing but the voltage shift as well as the current shift. We're going to apply the concepts, and we're going to reduce a complicated network into the simplest form. Later we are going to see the concept of the star delta transformation. If the circuit contains the resistors and the which are connected in the form of the series, parallel, and in the complicated manner. So without if it is not possible to apply the series and parallel connection. So in that case, we are going to make use of the concept of star delta transformation, and we are going to simplify the network into the simplest form. So that is called as a network reduction using the star delta. So that one is the second concept we are going to study in this module. Later on, we are going to see the concept of the Kirchhoff's voltage law and Kirchhoff's current law we are going to apply. So in order to perform the loop analysis, or it is also called as the mesh analysis, we are going to call and other one is called as a node analysis. So where we are going to apply the concept of the Kirchhoff's current law we are going to apply, and we are going to reduce the network into the simplest one we are going to reduce, and we are going to find out the node that is the mesh currents we are going to find out, and also we are going to find the node voltages we are going to find out. And in some complicated sources, we are going to call it as a super mesh and the super node analysis we are going to perform for the AC and the DC networks, and we are going to find the current and voltage in this one. So this is a basic module in which where the application of this module can be applicable in the rest of the modules, and these concepts are very important in the network theory for the rest of the modules. So in the module 2, we are going to study the network theorems you are going to study. So where the complicated network we are going to retain like that only. By applying the different theorems, we are going to find the current or voltage in any part of the network you are going to find out. The first theorem is called as a superposition theorem, where it is going to apply the concepts of the linearity we are going to apply in order to find the voltage or the current in the complicated network. The next one is the Millman's theorem, where we are going to reduce a number of multiple voltage sources or the current sources into the simplest single voltage source and the current source. That is the way we are going to apply the Millman's theorem. The next one is a very important theorem, the Thevenin's theorem, this Thevenin's theorem plays very important role. And here we are going to reduce a complicated network between the any two nodes into the simplest one, which consists of the voltage source in series with the current. And we are going to see in the Thevenin's theorem we are going to study. And the next one is called as the Norton's theorem. So the Norton's theorem is it's a current shift, or it is a source transformation of the Thevenin's theorem. So the voltage source can be replaced by the current source by that forms the Norton's theorem. So where the complicated network will be replaced by the simplest one, which consists of the current source in parallel with the resistance. And the next one is called as the maximum power transfer theorem. So this theorem is applicable in the most of the circuit elements where we have the practical applications of the RF and microwave design. So this theorem will be shows when the source can deliver the maximum power to the load. So based on this one, it is having the wide variety of applications are there. So that one you are going to study for the different DC and the AC sources. Next, we are going to see the concept of the reciprocity theorem, where we are going to replace the source with the excitation with the response you are going to replace, and vice versa, and we are going to verify this one. So these are the 6 different types of theorems we are going to study and to find the voltage or current across any part of the circuit. So in the module 3, we are going to make use of the switching conditions of the network you are going to consider. So the best example for the switching conditions is the fan, where we are going to consider the capacitor, and the tube light, where we are going to consider the example of the inductor. So as soon as switch on, the fan is having the capacitor will be there. It will take some time to charge so that the fan will start rotating. After when the charges in the capacitor reaches maximum, so the fan rotates at the maximum speed. That is the example for the capacitor. That's an example for the switching condition we can take. And similarly, the inductor is present in the tube light. That will play a very important role. So in this module, we are going to study the behavior of the circuit elements of the switching conditions of the resistor, inductor, and the capacitor. And we are going to see the initial and final conditions once the switch is on and before the switch is on. For the different combinations we are going to study, that is for the resistance in series with the inductor, parallel with the inductor, and resistance in series or parallel with the capacitor, and the combination of the RLC, either it may be the series or the parallel combination, and both for the AC source and as well as for the DC source, we are going to see that one. So this is very simplest and also the very important one, where we are going to study the different the switching conditions will be studied. So in the module 4, we are going to see the concepts of the Laplace transformations. So since the Laplace transform is applicable for the analog systems, so since the system is nothing but the circuit element contains the resistor, capacitor, and inductor, so this is the analog system where we are going to apply the Laplace transform for the different components, and we are going to solve the complicated network to find the current and the voltage for the different excitations we are going to apply, and we are going to evaluate. And in the Laplace transform, you're going to see the introduction and some of the basic Laplace transform of the some general functions you're going to study. Afterwards, you're going to find the Laplace transform of the step function, ramp, and impulse responses you're going to see. And as well as we are going to find the Laplace transform for the periodic waveforms. Periodic signal is nothing but suppose if the signal is repeating periodically, we are going to find out the Laplace transform of the periodic functions. And we are going to synthesize the waveforms. For example, it may be the sinusoidal, or it may be the triangular, the sawtooth waveform. We are going to synthesize that one. So at the end, we are going to find the solution of the networks to find the current and the voltage in the network. We are going to study, and we are going to find that one in this module. And this Laplace transform will play a very important role, where if it is not possible to find the solution in the time domain, then we go for the Laplace domain and we'll find the solution, and we are going to convert back into the time domain sequence. So that's what we are going to study in the Laplace transform. Then in the module 5, it consists of the combination of the many things are there. One is called as a two-port networks, where we are going to study the various different types of network elements, so network parameters such as Z parameters, that is impedance parameter, admittance parameter, the transmission parameters, and the hybrid parameters you are going to study. And we are going to model the network into these parameter elements you are going to model. And we are going to study the relationship between the different types of parameters you are going to study in these two-port networks at the initial one. So later, we are going to see the concept of the resonance. We are going to see so resonance for the series resonance, and we have the parallel resonance circuit. For the resonance circuit, we are going to find out the series resonance, the variation of the current and voltage with respect to the frequency, and we are going to derive the expression for the resonant frequency, and also the factors, some of the factors such as the selectivity, bandwidth, quality factor, and some circuit magnification factor. All those things you are going to study with the variation of the capacitance and many more parameters you are going to study, and you are going to solve the problems to find the resonance, different resonance conditions. So in the next half of remaining part of the module 5, we are going to see the concept of the parallel resonance, where we are going to find the condition for the anti-resonance. We are going to find out, and we are going to find the network parameters such as selectivity, bandwidth, all those things we are going to study, and also the many different cases we are going to study for the parallel resonance circuit. So these are the 5 models where going to study in the network theory, and the very important one is a module 1 where we are studying the basic components. So that basic concept will be helpful for the rest of the remaining 4 modules. And let us come into the textbooks. So the network analysis, we have the 2 textbooks. Other one is network analysis by Van Valkenburg. It's a very good one. The concepts are given nicely, and also network systems by the D. Rai Chaudhary. And these are some of the references books, engineering circuit analysis, and these are some of the reference book we can refer for the network theory subject. It's a very good subject, and it plays very important role in the competitive exams such as the gate exams. So network theory will be having almost 12 to 20 marks will be there, and this subject will play a very vital role in clearing the gate exam.